Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe and press the bell icon near the subscribe button so that you get the notifications of my latest videos, and do not forget to like and share the video. We'll be continuing this chapter, Light, Reflection and Refraction, which belongs to the chapter 1 of physics and chapter 10 of NCERT. Our topic for today is ray diagrams for convex lenses. We'll be studying about the nature, position of the image and size of the image formed by convex lenses today. So our first ray diagram, we'll be going one by one, and we have totally 6 ray diagrams over here. Alright, our first ray diagram, and our object is placed somewhere at infinity. First let me draw the lens. This is the convex lens. The optical center. Alright. Then this is F1, F2. Make sure that when you draw this F1 and F2, this OF1 should be equal to OF2 because this is the focal length. Alright. But since I do not have exact values, I'm drawing with the approximate values. Since I don't have scale, compass and all over here, I'm drawing it like this. But whenever you draw in your notebook or whenever you practice it, practice properly with scale, pencil, compass, eraser, whatever equipments are required. Okay. Then here is 2F1 and this is 2F2. This line is my principal axis. Alright. The object is at infinity. So rays from infinity emerge and incident on this convex lens. Alright. Since the object is at infinity, I'm not drawing the object since it's very big. So here is the incident ray. I'm taking another incident ray like this because I'm considering only 2 rays. Alright. Now after refraction, what will happen? It will go and refract like this, pass through the F2 of the convex lens. Alright. This is the other refracted ray. Now where the 2 refracted rays meet? At this point. And what is this? This is F2. Alright. So here is the image formed. So I go on with my 4 points. First, let me write here. Where is the object placed? Object is at infinity. Okay. Position, object position. Object position at infinity. Second point. Where is the image position? Image position. It is at F2. At F2. Third one. What is or how is the size of the image? Image size. It is point sized. It is highly diminished. See, very small, like a point. So it is point sized. Alright. Or highly diminished. Highly diminished. Alright. Next, nature of the image. It is real and inverted. Okay. Nature of image, real and inverted. So this was about the first ray diagram. Second ray diagram. In the second ray diagram, we will be bringing the object little bit closer to the lens, to the convex lens. Alright. Now I am teaching you about converging lens. That is the convex lens, the other name of convex lens. Now second ray diagram. I take the convex lens This is the optic center. Then F1, F2, to F1, to F2. This is the principal axis. I told you that we'll be bringing the object little bit closer. So now in the first case the object was at infinity. In the second case it is beyond to F1. Alright. So this is my object. This is the object. Alright. A, B. Rays from this object emerge and incident on this convex lens. One incident ray. Now after refraction, where will this incident ray go? It will pass through F2. Remember the important path rays that I taught you in the last video. Now in the second, I am taking the second ray. The second ray, I am taking it to be passing through this optical center. So after refraction, it will refract without any deviation. It means it will go same like that. So this passes through the optical center, goes like this, straight. This is the refracted ray. This is the incident ray. Now these two refracted rays meet at this point, which means the image is formed somewhere over here. A, and this is A, and this part is B. So I write B over here. Alright. Now we see all the 4 points. Where is the object? Object is at infinity. At infinity. Second one. Where is the image? The image is image position. Okay. Image is between F2 and 2F2. Between F2 and 2F2. Somewhere between these 2 points the image lies. Third one. Where or how is the image size? How is the size of the image? Image size of the image is diminished. It is smaller than that of the object. Okay. So diminished. And how is the nature of the image? It is real and inverted. Okay. So nature of image, it is real and inverted. Real and inverted. Now I go on to the third ray diagram. Now in the third ray diagram we'll be bringing the object even more closer to the convex lens. I draw only the I erase only these rays. F2 to F2. Third ray diagram. I told you that we'll be bringing the object closer to the convex lens. Now the third ray diagram, my object is at 2F1. This is the object A, B. Alright. Now I take 2 incident rays. One from here, one from the top. Okay. Now after refraction, where will it go? It will pass through F2. Now second ray, it goes through optic center, passes without any deviation. Okay, this is the incident ray, and after refraction passes without any deviation, so goes straight. This is the refracted ray. The 2 refracted rays meet at this point at 2F2. F2. Alright. This is A. I mark A over here. And this is B. I mark B over here. So again we go with all our 4 points. Where is the object? Object position at 2F1. Okay. Object position 2f1. Second point, position of image. Where is the image? At 2f2. Nice now. You see here, at 2f1 is the object and at 2f2 is the image. Very easy to remember. So image position 2f2. Next, size of the image. Image size of the image, it is the same size, okay. And what is the nature of the image? How is the image? It is real and inverted. So nature of image, real and inverted. Alright, now we go on to the fourth ray diagram. Now we'll be bringing the object closer again to the convex lens. We'll be bringing it between 2f1 and between f1. Our object position will be between 2f1 and between f1. This is f2, 2f2 and fourth ray diagram, number 4. This is the object A, B. Alright. You can take L, M, N, X, Y, whatever the letter you like. Then I take 2 incident rays. One from here. After refraction, it passes through f2. Then I take another incident ray that passes through this optic center. After refraction, it emerges without any deviation, I told you, right? So, wait. It emerges like this. I extend this ray so that they meet at a point. Where does it meet? It meets at this point. So here my image is formed. This is A, I mark A over here. This is B, I mark B over here. So I'll tell you all the 4 points again. Where is the object? Object position. Object position. It is between f1 and 2f1. Between f1 and 2f1. Second one, position of the image. Where is the image? It is, image position. It is beyond 2f2. Okay, it is beyond 2f2. Next, what is the size of the image? How is the size of the image? It is enlarged. Image size. It is enlarged, bigger than that of the object. Okay. And the fourth point, how is the nature of the image? Again, it is real and inverted. Nature of image, real and inverted. Alright. Now we move on to the fifth ray diagram related to convex lenses. We'll be again bringing the object closer to the lens. Now, number 5. The object is at f1. The object is placed at f1. A, B. This is my first incident ray. After refraction, passes through f2. This is a refracted ray. Another incident ray goes through this optical center. after refraction emerges like this. Now you see that these two rays will meet somewhere at infinity. So I draw these dotted lines and write at infinity. Okay, which means my image will not meet somewhere near in this board itself. It will meet somewhere else, somewhere at infinity. So again I write all the 4 points. Number 1, object position at F1. Object position at F1. Then the position of the image position at infinity. Next, relative size of the image. Size of the image. Now since it is formed at infinity, you can imagine how big your image can be, which means it is infinitely large or highly enlarged. Okay, infinitely large or highly enlarged. You can use any of the two terms. Highly enlarged. Next, the nature of the image. Nature of image. It is real and inverted. Okay. Now finally we move on to our final and 6th ray diagram related to convex lenses. Again we'll be bringing our object closer to this convex lens. This is F1 to F1. Okay. So in our previous ray diagram, where was our object? It was at F1. Now we'll be bringing it even more closer, which means it is between F1 and the optical center. Okay. So my object is somewhere over. F1. This is 2F1. I draw my object somewhere here. A, B. The incident ray goes like this and passes through F2, the refracted ray, but comes actually somewhere from this point, somewhere here. Okay, and another incident ray goes like this through this optical center, passes without any deviation, comes actually from somewhere at this point. Okay, these both rays actually come from this point. Okay, so they meet at this point. You can see it clearly. That means my image is actually found over here. This is my image A and this is B. Alright. The only different case in this convex lenses, ray diagrams related to convex lenses. So first point, where is the object? Object position. Object is between this F1 and optical center. So between F1 and optical center. Second one, where is the image? Where is the image formed? It is formed on the same side of the lens as the object. Okay, image position, same side of the lens as the object. on the same size. Next, size of the image. Size of image. It is enlarged, bigger than that of the object. Okay, enlarged. And the fourth one, nature of the image. How is it? How is the image? Is it real and inverted? No, it is virtual and erect. Nature of image. It is virtual and erect. So I end my video over here. If you have any doubt, do ask me in the comment section, or if you want me to make a video on a particular topic from any subject, even that, do mention in the comment section.